Alright, in today's video we're going to look at some of the problems from this volume worksheet in Advanced Grade 9 Science. We'll do this probably in 2 video clips, and I'm not going to solve all of the problems, but I'll do a good number with you. So the first question we'll look at is number 3 on the problem sheet. We're shown a triangular prism, and we're told that it has a height of 9 yards and a base with a right triangle where the legs of that triangle are 7 and 5 yards long. So let's translate that. Here's the right triangle face, the base of the prism. The legs of the right triangle mean the two sides that meet at the 90-degree angle. So one of those legs is 5 yards, the other leg is 7 yards. The height of this prism would be this edge here. That'll be 9 yards, 9.0 yards long. We're asked to find the volume and express that volume in cubic meters, and it gives us a hint to use 12 unit multipliers to do that. So if you think you know what you're doing, pause the video and try the question yourself, or follow with me and check your work. So this is how your work should be shown on loose leaf. Question number 3. I don't need to redraw the picture, but I'll start with a formula. The volume of a prism is equal to the area of the base times the height. Okay, there's the basic formula for any kind of regular solid. So now the area of this base was that triangle. So the triangle here would be 1/2 times its base times its height. That's the formula for area of a triangle. And then I don't want to use the letter H again because I just used it here for height of the triangle. So here for height of the prism, why don't we just use L? Okay? L for length or something like that. The letters you use aren't important as long as you remember what they stand for. So now in our problem, we had the base of that triangle was 5 yards, so 1/2 times 5 yards, and the height of that right triangle was 7 yards, so 7.0 yards. The height of the prism, in this case L, was 9.0 yards. And so now grabbing a calculator, we'll evaluate this. Now just looking at this, we're going to keep 2 significant digits in the answer because each of these dimensions has 2 digits. So 0.5, half, times 5 times 7 times 9. Now notice when I type those numbers on the calculator, I'm not putting 0.0 because to the calculator 5.0 and 5 mean the same thing. So I don't really need to put the 0.0s. Equals 157.5, 157.5. Now these were each yards, which means this will be cubic yard. Remember that volume can always be expressed as a distance unit, in this case yards, if it's cubed. So distance cubed is a volume unit. Now technically I should round that off to 2 digits, so if I wanted the volume expressed in cubic yards, it would be instead of 157.5, if I can only keep 2 digits, I'd have to keep 160. And then to make it perfectly clear that it's 2 digits, I would switch it to scientific notation, 1.6 times 10 to the 2 cubic yards. Now on a test, if you kept 1 extra digit, you're supposed to keep 2, but you kept 3, you'd receive full marks. So if somebody wrote 158 cubic yards as your answer, you would also receive full marks on a test for me. The correct answer, though, was this one, 1.6 times 10 to the 2. Now the question said, convert that to cubic meters. So let me take the original non-rounded off answer, 157.5 cubic yards, and let's see if we can switch this from cubic yards to cubic meters. Now if you know how many cubic yards are in a cubic meter, you could do that with 1 unit multiplier. I don't know how many cubic yards are in a cubic meter, so I'm going to take a very roundabout way to do this. Okay, so we're using unit multipliers. Because this is yards cubed, we're going to have to use 3 unit multipliers that will convert yards into something else, and you're using it 3 times because this was cubed. It means there's yard times yard times yard. So by putting 3 yards like this on the bottom of the unit multiplier, these yards will give me a cubic yard, which will cancel with this out here. Now, what do I know about yards? It's an American unit. You might not remember this or might not even have ever heard this, but I know that there are 3 feet in 1 yard. That's a basic recipe. So I can convert those yards into feet. And if I do that 3 times, I'm going to now have cubic feet. So 3 feet are in 1 yard. 3 feet are in 1 yard. 3 feet in 1 yard. So if I take my original volume, multiply by 3, again by 3, and again by 3, I'll have converted to cubic feet. But the question wanted cubic meters. So let's just keep playing this game. If we put 3 more multipliers, we can get rid of the feet, the cubic feet, and I suppose, even though it feels like we're not getting to meters, we can switch that to cubic inches. Okay, because most of us know that there are 12 inches, I hope, in 1 foot. 12 inches in 1 foot, 12 inches in 1 foot. So now these feet are gone, and we're left with cubic inches as our units. So we've now converted cubic yards into cubic inches. Let's add 3 more multipliers. I'm going to go down here, just because I'm running out of room. We can convert the inches to centimeters 3 times because it's a cubic inch. And I know from a recipe that 1 inch is 2.54 centimeters. You need to know that. So if you didn't know that, put it down as something to memorize. 2.54 centimeters in 1 inch. So now these inches on the bottom will cancel with the inches on the top, and we're left with centimeter times centimeter times centimeter. We're left with cubic centimeter. Well, finally the end is in sight because we can get to cubic meters by switching centimeters to meters. 3 times again, centimeter to meter, centimeter to meter. 1 meter has 100 centimeters. A lot of people forget how many centimeters are in a meter, but just think of another word that starts with cent, or even just think of cents. There's 100 cents in a dollar. There's 100 years in a century. And so in the same way, there's 100 centimeters in a meter. Okay? So now centimeters cancel, and we're left with meter times meter times meter, which is going to give me cubic meter, which was asked for in the question. Now, when you're using unit multipliers, we can ignore all of the ones. A 1, if it's being multiplied by 1 or divided by 1, won't change anything. Numbers that are on top, like these 3s and these 12s and these 2.54s, if they're on top of the unit multiplier, we multiply by them. The 100s are on the bottom of the unit multiplier, so we're going to divide by them. So on our calculator, 157.5 times 3 times 3 times 3 times 12 times 12 times 12 times 2.54 3 times, and then divided by 100, divided by 100, divided by 100, and we get a final answer of 120.4 cubic meters. Now we needed that with only 2 significant digits, you remember. So if we round that off, it'll be 120, and we'll switch that to scientific notation to be extra clear, 1.2 times 10 to the 2 cubic meters. All right? Now if you had used 158 instead of 157.5, how would that affect your answer? Well, 158 times 3 times 3 times 3, and then times 12 times 12 times 12 times 2.54 times 2.54 times 2.54. Divide by 100, divide by 100, and divide by 100. Your answer is 120.8. So it's similar, but a little bit different from this one. Either answer would be correct. Okay, and of course, if you round off 120.8, you might say 121, which is 120, 121. It's essentially the same answer. All right, so let's take a look at another problem. Question number 4. You have a swimming pool. It's a rectangular prism, as you can see in the picture. We can see that it's 25 feet by 15 feet by 9 feet. Estimate the volume of water in the pool in gallons when it's completely full. And then we're given this little recipe that a gallon is about 0.134 cubic feet. Well, I notice that if I leave my units here in feet, I can find the volume in cubic feet. And then, using this little recipe, we can use 1 unit multiplier to switch cubic feet into gallons. So there's our plan. Find the volume in cubic feet, and then switch it to gallons using this recipe. So since we have a box, a rectangular prism, essentially, we know that the volume of that is length times width times height. Now, if you notice the two problems we've done so far, we're doing a second one now. Look at the pattern. I show my formula. I put numbers into the formula. I get an answer including appropriate units. And then if needed, we switch that answer into other units using unit multipliers if we were requested to do that. That's a well laid out answer. So there's my formula. Volume is length times width times height. We'll put our numbers in. The 25 feet by 15 feet by 9 feet. And so the volume of this swimming pool is 25 times 15 times 9, 3,375 cubic feet. Now, if we wanted the answer left in cubic feet, we would note that there's 2 significant digits in these 2 measurements, but only 1 significant digit in this measurement. That means our volume would have to be rounded off to 1 significant digit. When you multiply or divide with measurements, round off the answer to have the same number of significant digits as the number that had the fewest in the calculation. So if I want to write that with 1 significant digit, 3,375, right now it has 4 digits, I can only keep this first digit. So the second digit's a 3, that means I can round that off to just say 3,000. But if I write 3,000, it's really not clear if I mean just the 3 and a 0, the 3 and 2 zeros, or all 4 numbers. So switching that to scientific notation is always a safe thing to do. This will be 3 times 10 to the 3 cubic feet. And now we've expressed it with 1 significant digit. If you understand the calculation, but it's the rounding off to the correct number of significant digits which is making your answers wrong, then don't feel like you don't understand how to do these problems. You do understand how to do the volume problem. It's the significant digits part that you want to get some help on, or maybe the switching to scientific notation. So when you're struggling with homework like this, try to be specific about where you're struggling. You'll then feel better about yourself. You'll realize you do know certain things in the problem, and then you'll be able to diagnose exactly where you need some help. I need help with maybe you need help with choosing the right formula. Maybe you need help with rounding off to the right number of digits. Maybe it's converting the units. Let's do that here. We're going to convert this answer, 3,375 cubic feet. We're going to convert it to gallons. Maybe it's unit multipliers, which is bothering you because you're new to that. Cubic feet to gallon, we were given a recipe to do that. 1 gallon is 0.134 cubic feet, which means we can switch these units with just 1 unit multiplier. We can get rid of the cubic feet and switch directly to gallons. 1 gallon is 0.134 cubic feet. When we ignore the 1, because to multiply by 1 doesn't change anything, the 0.134 is in the denominator of my unit multiplier, so I'm going to divide by that. So 3375 divided by 0.134 is 25,186 point something, so 25,187, I'll say, gallons. And now let's round that number off so it has just one significant digit. Remember, we can only keep one digit in this answer because of this 9 in the original problem. So 25,000, if we can only keep the first digit, the one digit, we'll have to round off 25,000. We'll have to round it up to 30,000, right, to keep just one digit, because there's a 5 after the 2. This will become 30,000 gallons. And then to be extra clear, let's switch it to scientific notation. 3 times 10 to the power of 1, 2, 3, 4. 3 times 10 to the 4 gallons. All right, so we found the answer with a formula, putting our numbers in the formula, evaluating that with a calculator, rounding off that answer with the correct number of significant digits. When we converted to the units of gallons, I used the original answer and then rounded it off again at the end. All right, let's try another problem. Question number 5 shows us a slanted cylinder. Okay, a cylinder with a bit of a twist to it. It says find the volume of the cylinder. Then it says give your answer in terms of pi. That's probably a little strange to you. And then instead of paying attention to significant digits, it says here rounded to the nearest tenth. Okay, so we're going to round off to the first decimal place in our answer. So in this weird-looking cylinder, we notice that the bottom is showing us the diameter. 18 inches is the distance from one end to the other end of that circular base. It's the diameter, which means we're going to need this. The radius will be half of that. The height, when you have a slanted cylinder like this, is simply the distance, as it shows us here, from the top straight down to the base. And I know it's straight down because this little symbol here means a 90-degree angle. That's the important thing. So the distance, the vertical height, straight down, 90-degree angle to the base, is 14 inches. The formula for volume of any cylinder, whether it's at a slant or not, is the same. It's simply area of the base times the height. So let's jump in and try that. Question number 5, the volume of this cylinder is equal to area of the base times the height. And in this case, the base was a circle, right? It was a circular base. So area of a circle is pi times r squared times the height. So there we have it. Area of the base, pi r squared, times height. Now the radius of that cylinder would be half of the diameter. So let me just show that. The radius is half of the diameter, which is half of 18 inches, which is going to be 9.0 inches. Now why did I write 9.0 instead of just 9? Because now on a calculator they mean the same thing. But in science, if 18 has 2 significant digits, when we divide that by 2, we'll keep 2 significant digits in that answer. So now let's put our numbers in. What should you use? What should you use for pi? Well, if you have a calculator with a pi button, you could use that. If you want to use 3.14, that will work for almost every problem. In fact, it will work for every problem we'll see in science. If you want to be a little more precise, 3.14159 would be a few more digits in pi. Pi, of course, is an irrational number. It goes on forever and ever and ever without repeating. So where you round it off is a little bit arbitrary. 3.14 will almost always work for us. The radius, 9.0 inches squared, and then the height of that cylinder was 14 inches. So notice inches squared times inches, this is going to give us inches cubed, or cubic inches, as our units. So with our calculator, 3.14 times 9.0. Now, if you want to multiply by 9.0 again, 9 times 9 is what 9 squared means. That'll work. Or I can just press the squared button on my calculator. I've got a button here that says squared, and then times 14. So I get this rather large volume, 3,560.76, 3,561 cubic inches. But we're going to round it off to have, oops, we weren't going to look at sig figs for this, were we? It actually said to round off to the nearest tenth. So this is going to be 3,560.8. If we look back at our calculator, 3,560.76. The tenths place would be the first decimal. So since it's 0.76, it'll round up to 0.8. Now, if you're paying attention, we actually didn't do something that we were asked to. It said to leave the answer in terms of pi. We didn't do that. We represented pi as 3.14. So let's now represent it in terms of pi. If we do that, we'll not use 3.14. We'll just use pi, the symbol, times 9.0 squared times 14. And then what we'll do is we'll evaluate the 9.0 squared times 14. So 9 squared times 14. That gives me 1134. 1134 pi. And now the question said, it was a little silly question, it said round off in terms of tenths. It doesn't really make sense here because this number is a whole number. I suppose we could say 1134.0 pi. Now it's got the tenths place shown. Okay? So this answer here, because we didn't actually put in 3.14 and multiplied by this, we're leaving the symbol pi. That means in terms of pi. Okay, it's still there, still multiplying, but we didn't actually do that multiplication. Okay, the original answer we had, we multiplied by pi and got this answer. So this is not in terms of pi. Question number 8. Let's jump, we're going to skip a couple. Question number 8 shows us a pyramid, a square-based pyramid, and it's got edges of 9 centimeters each. And it tells us in the question that the height of the pyramid is 14 centimeters. Calculate the volume of that pyramid. Well, the volume of a pyramid is like a volume of a cone. It's equal to area of the base times the height, and then divide by 3. So for cones and pyramids, objects that come to a point, we take the area times the height, and then we divide by 3. The area in this case was a square, so we could either say length times width, or we can say S, the side, squared. Okay, I'll say length times width, and then times the height, and then divide by 3. So there we go. The length was 9 centimeters. The width was 9 centimeters. That's the area of the base. And then the height was 14 centimeters. And then we divide by 3. Equals 9 times 9 times 14, divide by 3, 378, and these were all centimeters, so centimeters cubed. Now what about rounding off the answer? These two dimensions had only one digit. This one has 2 digits, so we can keep only one digit in this answer when we multiply and divide. Notice I'm ignoring the 3. When you're rounding off, you don't use the 3 from the formula because that's not a measured 3, that's an exact 3. Only round off based on the measurements, the lengths, the widths, the heights, things like that. So in this case, rounding it off to just one digit, the first digit, we'll have to round it up from a 3 to a 4 and call it 400 because the next digit is a 7. So this will become 400, and then to be very clear in scientific notation, 4.4 times 10 to the power of 2. And that's cubic centimeters. All right? Now again, if you have the formula shown, your number shown, and you got 378, then you understand 90% of this problem. If it's that last bit that's bothering you, then come in and get some help on just rounding off by significant digits. You understand the volume part of the problem, but it's the significant digits portion that's bothering you. Maybe we'll do one more problem here, question number 10. Find the volume of a cone with the base circumference 25 pi inches and a height 2 inches more than twice the radius. Well, that's a little irritating, isn't it? The circumference of this cone is 25 pi inches. The height is 2 inches more than twice the radius. So let's jump in and try that. Maybe a picture would help here. We have a cone, and we're told the circumference of the cone was equal to 25 pi inches. And we're told that the height of the cone, kind of strange, 2 inches more than twice the radius. Well, twice the radius would be 2r, and 2 inches more than that would be plus 2. There we go. There's the height. So how can we find the volume of this? Well, it's a cone, so a cone's volume is like the volume of a pyramid. It's equal to area of the base times the height divided by 3. Whenever the shape comes to a point, like a cone or a pyramid, we divide by 3. The area of this base, well, it's a circle. The area of a circle would be pi times radius squared times the height divided by 3. Well, we're at a little bit of a problem because we don't know the radius and we don't really know the height. The height's twice the radius plus 2, but we don't know the radius. So where do we go from here? Well, we do know the circumference. So if we think about that for a minute, the circumference of a circle is pi times its diameter. And so if you know the circumference, you can divide that by pi to give you your diameter. So let's do that here. 25 pi was the circumference, and we'll divide that by pi. I don't even need to grab a calculator. The pi will just cancel, and so we get a diameter of 25 inches. Look at that. That worked out nicely. Since the diameter of the circle is 25 inches, the radius of the circle will be half of the diameter. So 25 inches divided by 2, I'm going to keep an extra digit at this point, 12.5 inches. So now we have the radius, let's go find the height. The height was twice the radius plus 2. Well, twice the radius, that's our diameter. So it's going to equal 25 plus 2 is equal to 27 inches. There's the height. So now we can take this height and this radius and go find our volume. Pi times the radius, 12.5 inches squared, times your height, 27 inches, and divide by 3. Grabbing a calculator. Did it say leave the answer in terms of pi? No, it didn't. So we'll use 3.14 for pi, and then we'll multiply that by 12.5 squared, and then we'll times by 27, and we'll divide by 3. 4,416, if I round it off. 4,416 cubic inches. Now, how many digits should we have kept? Well, there were only 2 digits in the height, and if you remember, there should have been only 2 digits in our radius as well. So I'll keep only 2 digits here. 4,416, I'll keep the first 2 digits. Rounding off, it'll be 4,400, or switching to scientific notation, 4.4 times 10 to the 3 cubic inches. Alright, so there's a handful of problems that illustrate some of the layout in a good answer, showing your formulas, putting numbers in, getting the answers evaluated with a calculator, including units, showing unit conversions where needed, paying some attention to significant digits in your answer as well. I'll put a second video up with some more answers tomorrow.